Good morning everyone. In today's session we are solving a third problem on module 1. So the problem is draw the per unit reactance diagram for a given power system network using a base of 100 MVA 220 kilovolt in 50 ohm transmission line. So please do underline the sentence. So in the problem they have given you need to take the transmission line value, that is 100 MVA and 220 kilovolt, as a base value or the reference value. So this is a given single line diagram and all the values are given below the single line diagram itself. So the generator is having the rating as 40 MVA 25 kilovolt and the reactance is 0.2 per unit. Similarly, the transformer T1, it is a step up transformer. Primary is having 33 kilovolt, secondary 220, 40 MVA and reactance is 0.15 per unit. Similarly, T2 and motor will be having the following ratings. So remember, the transmission line value they given it as a reference value. So by taking this as a base value, you need to calculate the base voltage of the generator and the motor. So both lies on the LT section. So now we'll proceed with the procedure. See, just look at the procedure once. The step 1 is choosing the base power for the entire system. So since the transmission line value they given it as a base value, so now MVA base will be equal to 100 MVA. So step 1, MVA base new, that is equal to 100 MVA. So next, proceeding with the step 2. Step 2 is nothing but it is the calculation of a base voltage for the different components. It may be for the generator, transmission line, motor and load. But in your problem we have only generator, transmission line and motor is there. So for these three components we need to calculate base voltage. But in the problem they have given transmission line value as a reference. So this value 220 kilovolt will be the kilovolt base new for the transmission line. So this will be the reference value here. So we can directly write kilovolt base new for the transmission line will be equal to 220 kilovolt. So this is nothing but the HT section base voltage. So now consider this will be your reference value. By taking this reference value, we will calculate the base voltage of the generator. Next we will calculate the base voltage of motor, since both lies on the LT section or the low tension section. So first we will write the formula for the LT section, kilovolt base for LT section, that is equal to kilovolt base on HT section, nothing but the transmission line multiplied by the transformer rating, that is low tension rating or the low voltage rating divided by high tension rating. So now since we are doing for the generator calculation here, LT for the generator, so kilovolt base on HT is nothing but always it will be the transmission line. So that base voltage is 220 kilovolt multiplied by the transformer ratings. So now look at the single line diagram. We are calculating the generator value as a base. So here the transmission line value given it as a reference here. So in between the transmission line and the generator we have T1 transformer is there. So this L low voltage and high voltage rating we need to write. So the low voltage will be 33 kilovolt and high voltage will be 220 kilovolt. So 220 get cancels, remaining is 33 kilovolt. So this is the base voltage for generator. Next, similarly using the same formula, calculate base voltage for the motor. So kilovolt base new for the motor, that is equal to kilovolt base on HT section. HT is always the transmission line. That base voltage we have already written here, that is 220 multiplied by low voltage rating by high voltage rating. So low voltage rating means it is the T2 transformer. See, observe here we have a motor and we have a transmission line is there. This we have considering as a reference. So in between the transmission line and a motor, T2 transformer is coming. So that rating you are supposed to write. So that is low voltage is 11 kilovolt, high voltage is 220 kilovolt. So cancelling this we get 11 kilovolt. So this completes step 2. Now proceeding with the step 3, that is calculation of reactance for the transformer. So now observe, the third step is the calculation of per unit reactance for the transmission line. So here you know that the transmission line value, it is given in ohms. So this ohmic value you need to convert into per unit. So how do you convert? Means using this formula. X per unit will be equal to X in ohm multiplied by MVA base nu divided by kilovolt base square nu of the transmission line. So I'll write this formula now. So we can write the reactance of transmission line is equal to X per unit nu for the transmission line, that is equal to X in ohm multiplied by MVA base nu divided by kilovolt base square nu of the transmission line. So now observe here, X in ohm, that is a reactance given for the transmission line in ohm. So that is J50 ohm. So here you can directly write it as J50 multiplied by MVA base nu. MVA base nu means, look at the step 1 value. Step 1 is 100 MVA divided by kilovolt base square nu of the transmission line. So nu means you have to see step 2 value. So kilovolt nu for the transmission line is 220 kilovolt whole square it is. So after substituting this, we will get the value for the transmission line as J0.103 per unit. So this completes step 3. So next, the step 4 is calculation of per unit reactance for all the components using this formula. So which all the components you are going to calculate the per unit reactance means, excluding transmission line, we have generator is there, T1, T2 transformer is there, and motor. So for all these components we are going to calculate per unit reactance by using this formula. So first we are going to proceed with the generator per unit reactance calculation. So this is the formula as I have written. So now look at the given data. Since you already know that what is the old value and what is the new value. Old value is nothing but the given data in the problem. So these are all the old values. New value is nothing but step 1 and step 2 values. Step 1, step 2 are the new values. So accordingly we will substitute the value of X per unit. So the first is X per unit old for the generator. So now look at the given data. Reactance old value given for the generator is 0.2 per unit multiplied by MVA base nu. MVA base nu means step 1 value, it is 100 MVA divided by MVA base old. Old is nothing but you have to see the given data, that is 25 kilovolt multiplied by kilovolt base square old. Old is nothing but the given data in the problem. Sorry, this is 40 MVA. MVA this will be 40 MVA, and the kilovolt base square old given in the problem is 25, and kilovolt base square new in the step 2, that is 33. So we will write 25 divided by 33 whole square. So after substituting this, we will get the answer as J0.281 per unit. So next, similarly we will do it for the motor using the same formula. X per unit new for the motor, use the same formula. X per unit old, look at the given data. The reactance given for the motor is 0.3 per unit. So this is 0.3 multiplied by MVA base new. New is nothing but you have to see step 1 value, that is MVA base new, it is 100 MVA divided by MVA base old, that is given data, it is 50 MVA multiplied by kilovolt base square old. Old is nothing but again given data, it is 11 kilovolt divided by kilovolt base square new, that is step 2 value. Kilovolt base new for the motor is 11 kilovolt. So after substituting this, we will get the answer for motor as J0.6 per unit. So next last is the calculation for both the transformer. See, observe the given data here. Transformer T1 and T2 both are having the different ratings. So what you have to do, you need to do two separate calculation for T1 transformer and also for the T2 transformer. Now X per unit volt, this is a formula for the transformer, same formula only. For the T1, X per unit volt. So now look at the T1 transformer data, it is 0.15 per unit. Multiplied by MVA base new. Again you have to see the step 1 value, it is 100 MVA, divided by MVA base old. Old is nothing but the given data, it is 40 MVA. Multiplied by kilovolt base square old by kilovolt base square new. So as I told you already, there is a slight change in the kilovolt calculation since the transformer is having two voltage rating, primary side and the secondary side. So now use this formula, kilovolt base square old. Old is nothing but the given data. Let us consider the base voltage calculation for the primary side, that is given data is 33, divided by this primary side of the transformer, it is connected to the generator G. So what is the new value of the generator? Why we have to take the new value means, look at the given formula, kilovolt base square new it is. So you have to see the primary side transformer connected to generator, so that generator new value. So that new value is 33 kilovolt. So here you can write 33 by 33 whole square, the answer is 1. Similarly, cross check for the secondary side. Secondary side, the volt value is 220, divided by this secondary, it is connected to the transmission line. The new value of the transmission line, kilovolt base new, is again 220. So on either side also, if you take the base value means the answer is same. So that means our step 1 and step 2 calculation is correct. So now either I can take the primary side or I can take the secondary side, because both the side we are getting the same answer. So now I will take the primary side value. So it is 220, secondary side value 220 by 220 whole square. So after substituting this, we will get the answer for T1 transformer as J 0.375 per unit. So next similarly do the calculation for the T2 transformer. X per unit new for transformer T2 is equal to X per unit old. So the old value given in the problem is 0.15 test. So this is 0.15 multiplied by MVA base new. New means again the step 1 value 100, divided by MVA base old. Old is nothing but given data, that is 30 MVA, multiplied by, same way we will do the calculation here. So kilovolt base square old. Old is nothing but the given data. Let us consider I am doing it on the primary side. It is 220 kilovolt, and this has been connected to transmission line. So the transmission line new value is also it is 220 kilovolt. So I dividing will get answer as 1. Next similarly cross check for the secondary side. So the kilovolt base square old value, old is nothing but given data, it is again 11, and this secondary is connected to motor. The motor new value, kilovolt base new will be, it is again 11 kilovolt. So 11 by 11, again you will get the answer as 1. So both the primary side and the secondary side we are getting the same answer. So any side you can consider the value here in the reactance calculation. 11 by 11, that is I have taken secondary side data, that is equal to, after substituting will get J 0.5 per unit. So this completes step 4, and the final step is drawing the per unit reactance diagram for a given single line diagram. Okay, so draw the final step. Now look at the given single line diagram here. So here we have one generator is there connected to transformer T1, transmission line, and T2 transformer, and then motor. So accordingly we'll write here. So first we'll write the reactance for the generator, and after that it is connected to the transformer T1. Next we have transmission line is there, and after that we have transformer T2 is there. Then we have one motor is there. So this is the reactance diagram. So this is the reference bus. This will be the X reactance for generator, and this is the source voltage. This is the reactance for motor, and this is the source voltage EM, and this is the reactance for transformer T1, reactance for transformer T2, and reactance for transmission line. So now write the values of all the components. So now I have written all the reactance values in the reactance or the impedance diagram. So this completes the given problem. Thank you.